Welcome everyone, thank you for coming today. My name is Todd Signetti and I have with me Ram Ramani. And this is session FND320. We're going to be talking about ACM Private CA, root CA hierarchies for AWS Certificate Manager Private CA. That's quite a mouthful, I know. So the agenda for today is to talk about the challenges of operating a private CA and how the ACM Private CA solves some of those challenges. We'll talk about use cases for ACM Private CA and have a demonstration of creating a root CA hierarchy, including a root and a subordinate CA. And then we'll talk about, that'll take about 10 minutes to show how it's done, but then we'll talk about the harder part, which is actually planning your CA hierarchy and some best practices for security around that. So we introduced ACM about 3.5 years ago. And ACM is our certificate manager. And while we were talking to customers about certificate management, a lot of them talked about the problems of certificate expiration and the problems of renewal. And we tried to solve that with ACM. But while we were talking to them in the area of certificates, what came up a lot was customers also told us they had a lot of problems managing and operating their own private CAs. And so about a year ago, we introduced ACM Private CA. And ACM Private CA is a managed private CA service without the upfront investment and ongoing maintenance costs of operating your own private CA. There's no need to build your own CA infrastructure with ACM Private CA. It's secure, it's backed by FIPS 140-2 level 3 HSMs, and there's no need for you to manage the HSMs, it's part of the service. And the access controls, auditing, and logging is built into the service. So all of the controls you would want to have in place around managing access to the CAs is built into the service. And you can configure these policies, you can customize them, but there are also AWS defined policies that are default managed policies that you can also use. And so one of the other benefits of and why we developed ACM Private CA is to enable developers to issue certificates for dynamic resources as they're building resources in the cloud, to give them APIs and give them the flexibility and agility to issue certificates to identify those devices and resources. And with Certificate Manager, we also integrated Certificate Manager with Private CA. So Certificate Manager gives you the benefits of central management for both public and private certificates. So as of last week, last Thursday, we launched a new feature of ACM Private CA, and we announced it publicly for the first time yesterday at the keynote here at Inforce. And that feature is root CA hierarchies for ACM Private CA. So previously, ACM Private CA acted as a subordinate CA that chained up to an external root CA. And you had to maintain that root CA or intermediate CA infrastructure, but we provided the subordinates. Now with root CA hierarchies, you can create a complete CA hierarchy, including the root and subordinate CAs with no need for external CAs. So we support the entire hierarchy from root to intermediate to subordinate issuing CAs. And the reason for having a root CA or a hierarchy of CAs is that a CA hierarchy provides strong security and restrictive access controls for CAs at the top of the hierarchy, like the root and top level or intermediates, while having more permissive access and bulk issuance for subordinate CAs. So allowing less restrictive access or more permissive access to subordinate issuing CAs, where in a cloud environment, you might want your developers to be able to issue end entity certificates by accessing the CA, but you don't want necessarily developers who aren't administrators to access your root CA or top level intermediates. So what this looks like, before ACM Private CA hierarchies, we had, in this diagram, the existing CA infrastructure was a root CA, an intermediate CA, either on premises or on a server running on an instance. And you could create an issuing CA, and to chain it up to your root, you generated a certificate signing request, signed it by your intermediate CA, and then took that CA certificate and imported it into your issuing CA.
At that point, your issuing CA was ready to issue trusted certificates that chained up to your root CA, and as long as that root CA's certificate is distributed in your environment, those end entity certificates would be trusted. And this gave our customers a way to issue bulk certificates for dynamic resources, and they liked this, but they asked us, they wanted more. We didn't solve the pain of operating the roots and the intermediate CAs. So now with ACM Private CA Hierarchies, the entire infrastructure can be hosted on AWS with ACM Private CA. A third-party external CA is now optional. Before it was required. The process for enabling an issuing CA is the same as it was before, creating the CA, generating a certificate signing request for that private key, signing it with the intermediate, and importing the CA certificate into the issuing CA. And Ram will show a demo, a 10-minute demo of how to create a 2-level hierarchy and how to use it to issue private certificates. That's in a few minutes. But first, let's talk about some of the reasons CAs are organized in a hierarchical structure. And this is basically a best practice. And the primary reason that we create hierarchy, it's such a common structure, is that it provides the most protection for the CAs at the top of the hierarchy. Those CAs are the most restricted, and have the most trust because any certificate issued that chains up to that root CA is trusted in that environment. And so we really want to protect against misissuance, particularly of a CA certificate that could be used in a way that's unconstrained, and a rogue CA issuing trusted certificates is something we definitely want to avoid. And so we really provide a lot of protection and access controls around the CAs at the top of the hierarchy. Conversely, we want to grant more permissive access to subordinate CAs because we want those CAs to be available and used to issue end entity certificates. Another reason for the CA hierarchy structure is to give the ability to delegate access on the CA boundary. Examples of this are if you have different groups or different projects and you want to have different CA administrators, you can delegate access to one CA for one project. Let's say an IoT application issuing certificates for devices has one CA administrator, and a CA that's issuing certificates for TLS endpoints within a cloud environment has a completely different management structure and control structure and policies to govern it. And so you can delegate access to those CAs and keep them chained up to the same root, but delegate access. And then auditing and alarms for every certificate we issue by the root is something we recommend. And we want to have these different policies. So if a root CA issues a certificate, that may be cause for an alarm, something you want to know about, because it's such a rare event that your root CA is generally used to only issue certificates for subordinate CAs. That's an uncommon operation. Whereas for subordinate issuing CAs, they issue certificates in bulk, maybe thousands of certificates per day. You want to audit random samples, but you're not going to have the bandwidth to look at every single certificate in depth. And so that's another reason why we have a hierarchy. So we can separate these controls and policies. Next, a question is, what can end entity certificates issued by private CA identify? So TLS endpoints and resources, things like websites, databases, servers, instances, containers. Anytime you have server-to-server communication connected with TLS, you can use TLS certificates issued by ACM Private CA. IPsec VPN endpoints is another application, either in conjunction with TLS running on top of TLS to provide an extra layer of protection, or instead of TLS, IPsec VPN provides secure network connectivity. Another use case or application is for dynamic cloud resources, resources like containers and instances that are created with auto-scaling or CloudFormation. Other automation that automatically creates resources can call ACM Private CA APIs to issue certificates to identify those resources. And finally, IoT devices. We have a lot of customers
issuing certificates in bulk to identify their IoT devices. One example is Alexa for Business uses ACM Private CA to identify Amazon Echo devices on enterprise WPA2 Wi-Fi networks. And there's a public use case on that, you can look it up. There's a couple use cases that are not well supported today involving certificate enrollment protocols. And the primary one that a lot of customers are asking for, and we're definitely considering for the future, is to issue ADCS, Active Directory Certificate Services, certificates that support auto-enrollment in a Microsoft ADCS environment. That's not supported today. It's something we're definitely thinking about. And the other common application that we hear from customers is to identify mobile devices over SCEP, Symbol Certificate Enrollment Protocol. And that's something, again, we're thinking about for the future. Some of the use cases that ACM Private CA supports today in creating a hierarchy, number one is to replace software or server-based CAs. How many of us are aware of developers or other folks in our organization that, for lack of a better solution, have created OpenSSL root CAs and are using them to issue certificates? The other alternative that I frequently see is developers or other individuals that are creating self-signed certificates. And ACM Private CA really provides a much better solution, fundamental security with HSM backing as an alternative to those cases. The other case that ACM Private CA supports, not on the slide, but replacing a CA that's backed by an HSM, that's an online CA backed by an HSM, where you are operating that infrastructure, you are operating those servers. ACM Private CA can replace that. The other use case that we're hearing is customers, and this is one that may not be for everyone, but to replace an offline root CA. We'll talk about the pros and cons of this. From a security perspective, I would tell you, you can't go wrong with an offline root CA. It's absolutely disconnected from the network. It requires physical access to issue certificates, and that's great. There are alternatives now where we can provide logical controls and logical isolation for an online root CA. If that meets your requirements, you can do that with ACM Private CA. The last use case is to complement an existing root CA. So if you have an existing root CA infrastructure and you want to do some testing or you want to get started quickly, you can stand up another root CA hierarchy on AWS and use that to identify resources in a limited trust zone. You can create a boundary of instances and resources that trust those certificates without going and using your external third-party CA. And that's a way to get started quickly with dev, test, and production on a cloud infrastructure with API-based certificates to identify resources. So at this point, Ram Ramani is going to demonstrate how to create a CA hierarchy. I'm just going to let this play.
We're going to show you a demonstration of ACM Private CA and use this diagram as the architecture. So in this architecture, there is an application load balancer, which is backed by a Lambda function. And the Lambda function supplies HTML code back to the application load balancer. The goal is to establish a secure TLS connection between this Firefox browser and the ALB. And the Firefox browser is going to hit this domain, acmdemo.com. This private domain, and the certificate for this private domain is going to come from the ACM service. The CA hierarchy that we will use for this demo is going to be having two levels. One is the root CA, and then the subordinate CA. The subordinate CA will issue an entity certificate that will go on the application load balancer. This is only one application of using a private certificate and for hitting a private website, but there are many others. So let's take a look at how this works. So I'm going to go to the AWS console under the AWS Certificate Manager service and click on Get Started under Private Certificate Authority. You have two options, either to create a root CA or a subordinate CA. We'll start with creating a root CA. Click Next, and then organization will type in as my company, leave the rest of the fields as blank, and common name, say my company root CA generation 1. You can have multiple certificates of different generations, but in this case, so this is the first one, I'm going to call it G1 or generation 1. And the certificate key algorithm is going to be RSA 2048. We will not enable CRL distribution for this demo. No tags as of now. And for configuring CA permissions or authorizing or denying ACM permissions to renew private subscriber certificates, we will deny it because we're not going to issue entity certificates using the root CA. Click next, and then make sure all the information is accurate. So you can see here that the information is as I typed it. If you want to change it, you can always change by editing it by clicking right here on this icon. So click to confirm that you understand that you'll be charged a monthly fee, and then confirm and create. So at this point, the root CA key pair has been created, and we'll click on Get Started to take the root CA CSR and sign it by the root CA's private key. Think of it as a self-signing mechanism. We'll set the validity to 10 years and the signature algorithm as SHA-256 with RSA. There are others if you choose to do so. Click Next, and then confirm and install. It takes about 2 to 3 seconds, and after which you will see on the console that there is an active root CA with the common name that we created, my company root CA G1. The next step for us is to create a subordinate CA. So click on Create CA, select Subordinate CA, and then you keep the same organization name, leave the other fields as blank, and the common name is going to be my company subordinate CA, again generation 1. Click Next. The certificate authority key algorithm RSA 2048. We will not enable CRL distribution for this demo. No tags. And in this case, I'm going to authorize ACM to use the CA for renewals because we're going to issue end entity certificates with this subordinate CA. Click Next. Make sure all the information is accurate. It looks good. And then click to confirm that you understand the pricing model and confirm and create. So the next step is to install this CA certificate to activate your subordinate CA. Let's get started. There are two options. One is you can either select the root CA that you actually own and you can bring that in, or you can use the root CA that you just created within the ACM PCA service. So we will go with the option where we will, the first option, ACM Private CA. Click Next, select the root CA that we just created with the common name, my company root CA G1. Let's set the validity to 3 years, and the signature algorithm is SHA-256 with RSA. And you see this parameter here called path length. The path length, you have 4 options. 0, you can set it to 0, 1, 2, or 3. We're going to set it as 0. Setting the path length to 0 means that this subordinate CA can issue only end entity certificates and not CA certificates. This is a security best practice to ensure that the subordinate CA is issuing, cannot issue a CA certificate. So let's click Next, and then click Generate. So there you can see now that there is a subordinate CA with the common name, my company subordinate CA G1. So next step for us is to go to the Certificate Manager and create a private certificate. So I'm going to request a private certificate and select the subordinate CA that we just created. And the domain I'm going to put it as alb.acmdemo.com. Review and request. Confirm that the domain looks good and the CA is the subordinate CA. Confirm and request. So it takes about 2 to 3 seconds, and you're going to have a private certificate for the domain alb.acmdemo.com. So there you go. The certificate is issued and ready to go. So let's now go to the EC2 service and find the load balancer on which we can put the private certificate. So just to let you know, this architecture that I showed earlier, this is pre-created. The ALB and the Lambda functions have been pre-created using a cloud formation template, so we're not going to create it manually during this demonstration. So let me go back here, go to the load balancer section, and you will see that there is a load balancer that has been pre-created. Let's go to the listeners, and I'm going to add an HTTPS listener. So the HTTPS listener will be listening on port 443. The default action is going to be forward to the Lambda origin, which is going to give the HTML code back to the ALB. And for the certificate, I'm going to select the certificate for the private domain that we just created and click Save. So at this point, the certificate has been applied to the ALB. So the next step for us is we're going to go and try to hit this private domain. Let's see what happens. So it says that the connection is not secure. The reason is that the root CA certificate is not available in the Firefox browser's trust store, and hence Firefox cannot trust this website. So the goal for us is to next put the root CA certificate inside the trust store of the Firefox browser. So I'm going to do this really quickly. So let me go back to the Certificate Manager service. And I'm going to go pick up the root CA certificate. So let me select the root CA and go to the CA certificate. And I'm going to download this certificate body to a file. All right. So this is called certificate.pem. So there you go. So this file. And I'm going to go to Firefox Preferences and import the certificate.pem. So let's go here. I'll do this quickly. Typically, in your organization, you would be using automation for importing root certificates into your trust store. I'm just doing this manually here. There you go. Okay. So at this point, I have actually added the root CA certificate into the trust store. So next, the goal for us is to see whether now the certificate is trusted and we are able to establish a secure connection with the ALB, and the Lambda code HTML is relayed back to the browser. So let's take a look. There you go. So you can see here that there's a trusted lock icon, and this private domain is trusted by the browser, which means that the private certificate is valid and trusted. And you can see the hello world has been given back by the Lambda function and relayed all the way back to the Firefox browser. So we were able to create a private certificate authority, a hierarchy, and then issue an end entity certificate, and then go back to the application load balancer and put that end entity certificate and make it trusted by the Firefox browser. Thank you. This is what I wanted to show you. Thanks.
Thank you, Ram. So now that Ram showed how easy it is to create the hierarchy, I want to talk about some of the complexities and things you need to think about, because as we all know, PKI infrastructure tends to last a long time. He showed in the demo a root lasting validity period of 10 years. So we want to think carefully about our environment and the CA infrastructure that we create. So some of the things, this is probably a partial list. So some of the things we want to think about are the key types and key sizes. RSA 2048 is the most common, most accepted key size and key type, but some customers have a requirement to use RSA 4096 certificates. And typically we see elliptic curve ECDSA certificates for customers who are issuing certificates for IoT devices because of the reduced complexity of processing smaller keys. So you want to think about those things. Next, revocation configuration. ACM Private CA can generate CRLs and send them to your S3 bucket. Ram didn't show that in the demo, but that's if he had clicked the button for CRLs, we would ask you for a bucket and send those to an S3 bucket. You want to make sure your S3 bucket is reachable from all of your clients that are going to be checking for certificate revocation. The other configuration setting we recommend is to create a C name or canonical name that's a level of indirection to your S3 bucket, so that the URI that goes into the certificates that the client uses to look up the CRL is using a friendly name instead of the exact bucket name. And that allows you some flexibility later if you want to or need to change the S3 bucket name. You won't have to reissue those certificates. They'll just use the same CNAME. Next thing to think about is AWS CloudTrail logging for all of your API calls. I strongly recommend turning this on so that you'll have an audit log of every API call made against your CA. You'll be able to go back and track and see all the information about the API call that was made. And of course, with a managed service like ACM Private CA, any operation that you take, any action that you take is done through an API call. Everything Ram showed in the console has an equivalent API and CLI command line interface command to create those resources using automation. And all of those API commands can be logged into CloudTrail so that you can see exactly what was done and go back in time. Next is CloudWatch metrics for alarms and notifications. ACM Private CA can send a CloudWatch metric for every certificate issued successfully, every failure, and every time a CRL is generated. So for example, for a root CA, you might want to take that CloudWatch metric and generate an alarm if the root CA issues a certificate. That's an uncommon operation. We talked about that before. But generating an alarm based on that will alert you if there's any unauthorized access or use of the root CA. Now, you wouldn't want to do that for bulk issuance subordinate CAs, but for roots it makes sense, or even high-level, top-level, intermediate CAs. Next, you want to think about audit reporting, and you want to think about who's doing the auditing, how frequently are they auditing, what are they looking for, and how are they matching up what they see in the audit report with what actually happened in your environment. Next are access policies, and I'll go into some depth about some of the logical access controls you can put in place. But you want to think about who can access the CAs, who's an administrator role, versus who has access to the CAs to only issue and revoke certificates. And we have, ACM Private CA has managed policies that allow you to, they're policies managed by AWS that you can use as a basis. I'll talk about those a bit more. And finally, the CA lifecycle management. How long is the validity period of your CAs? What is your plan for replacing a CA near the end of its lifetime? You have two options. The best practice is generally considered to be stand up a new CA and keep the old CA running until its lifetime expires, but with the new CA, start issuing new certificates from the new CA and so on. You also have the alternative to issue a new certificate with a longer lifetime, but that's something you want to think about and decide. So some security best practices, again, unless you know better ones, these are things that we've found in our environment at Amazon and from talking to customers that are best practices. Okay, so the most controversial one here, I think, at a security conference is to challenge the notion that of having an offline CA versus an online CA. And what an offline CA is essentially, it's a physical HSM, it's never connected to the network, and it's typically stored in a vault. So it requires physical access. Frequently, it requires two-person access to get to the CA. And of course, the main benefit of this is the no network access. It literally requires physical control of the device, and as long as you can control the physical access to the device, you can control what certificates are issued. And on top of that, usually the HSM has additional controls. You may have multi-person access. You may need 4 security officers out of 6 to walk around the HSM and enter their PIN codes before the HSM is operational. Of course, the alternative is logical access controls on an online CA, an online root CA. And the only benefit really there is that there's a couple benefits that you can provide logical access controls and restrict access logically instead of physically. And in the case where you have an operational event and you need to get to your CA, and there's a locked door between you and the root CA, and you can't get to it, or you don't have a quorum and you have to gather people and they're, it's 2 o'clock in the morning, an offline root CA can be a burden. An online root CA can give you a mechanism for convening a quorum more quickly and issuing in the event of an operational issue. And of course, you can have combinations. You can have an offline root that you rarely or if ever use, locked in a vault, and have a top-level intermediate CA in ACM Private CA that has a long lifetime. And you can set up, you can design this any way you want. But those are the pros and cons, some of the pros and cons of an online versus an offline root CA. So I've talked before a little bit about logical access controls, and here's some best practices around controlling access and isolating a root CA or a top-level intermediate CA. First of all, recommend using separate AWS accounts for your root CA or top-level intermediate CAs. And this allows you to strictly limit access to the account where the root CA lives so that only certain people, only certain groups have access to that account. You can have less restrictive policies for subordinate issuing CAs that allow your developers to issue certificates or the users of your certificates to have access to the subordinates, but they don't even have access to the AWS account where the root or top-level intermediates live. Within an account, for your subordinate CAs or issuing CAs, you can have IAM access controls. And the basic policies are to use AWS managed IAM policies. And with AWS managed policies, they're predefined policies managed by AWS. And for private CA, there are 5 predefined policies. There's full access, which is complete administrative access to do anything. There's a privileged user that is a CA administrator that only has the ability to issue CA certificates. And then a user, which has only the ability to issue end entity certificates to identify devices and resources. And then there's an auditor and a read-only managed policy. And I'll go into detail and show you what one of these policies looks like on the next slide. Another recommendation is to disable your intermediate and root CAs by default. The action of disabling the CA allows it to continue generating certificate revocation lists and posting them to S3, but no new certificates can be issued from that CA. And so one recommendation is to create custom policies where one group of users can only enable and disable the CA, and a distinct separate group can only issue certificates. And this gives you effectively 2-person control. To issue a certificate from the root requires one person from the first group to enable the CA, and a second person from a separate group to issue the certificate. And this is really a best practice for restricting access logically to a root or top-level intermediate CA. And since we're talking about access controls, I also want to talk about auditing and logging. It's important for your top-level roots and intermediates to configure auditing and logging so that you're carefully monitoring every certificate that these important top-level CAs are issuing. As I mentioned before, you can also alarm on every certificate issued by the root. And now let's look at an example privilege user managed policy for ACM Private CA. So what this policy, and this is just a part of the policy has different sections. This section is the one that controls the issue certificate action. And so what this does is the effect is allow, and the action is PCA issue certificate. So this is going to control who can issue certificates. And it's very specific. The resource, in this case, is any CA. You can actually narrow this down if you want to have different policies for different CAs. You can do that by specifying which resources this applies to. And the condition, string-like, references a template. And the way ACM Private CA issues CA certificates is you give it a template that tells it to issue a CA certificate. A CA certificate looks a little bit different than end entity certificates in that end entity certificates don't have the CA extension included, or basic constraints extension with CA true. They typically don't have basic constraints configured, whereas CA certificates have a basic constraints extension, CA true, and typically they have a path length specified. So what this policy does is say on the left side, it's allow this assigned user or group to issue CA certificates, and there's an explicit deny on the right side to issue certificates that are not CA certificates. And so what this user can do is, according to this policy, is only issue CA certificates and not issue end entity certificates. So this is a good policy for a CA administrator who really should only have access to managing the CAs and generating subordinate CAs. There's an equivalent policy for end entity certificates to allow issuance with a template for end entity certificates. Next, a couple points about constructing your CA hierarchy and how do we think about the hierarchy. One of the important constraints is what is the height of the CA hierarchy. And in this tree diagram, this has a height of 3, and that's basically counting each level, starting with the root and 1 for each level. And one thing we recommend is to use the path constraints I just talked about. It's an extension in the basic constraints that can configure and limit how many CAs are below this CA in the hierarchy. Really important for the subordinate CAs that have potentially, without this constraint, could issue CA certificates. What the path length constraint does is ensures that your subordinate issuing CAs cannot issue CA certificates, and that prevents them from issuing CA certificates that, if issued, could be used in an uncontrolled way to issue certificates for your environment. Path length constraint really prevents that from happening. Next recommendation is to reduce the height of the tree as much as possible, but not too much. So in cases where you need to delegate access to a CA, it's okay to put a level in your hierarchy for delegating access. But you want to use the minimum tree height because every time a TLS connection is established, the server is sending the entire certificate chain to the client. And the client has to check every CA certificate in the chain to validate that the certificate it wants to trust, the end entity certificate, is valid. And so the smaller we make that chain, we save network bandwidth and we save processing time for the client to validate the chain. Next, I want to talk about choosing the CA validity period. This is how long the CA lasts. The CA certificate has a validity period like any other certificate, and we want to think carefully about how we set that. The one constraint that we impose, and most CAs impose, is that CAs cannot and should not issue certificates that last longer or have a longer validity period than they do. And ACM Private CA enforces this constraint. And what this does, the reason we enforce it is because if the CA could issue a certificate that lasted longer than the CA certificate, what would happen is when the CA certificate expires, that instantly invalidates the certificate that it issued with the longer lifetime. Because as I talked about before, the path length, the chain checking, when the client is checking the chain, it's going to come across an invalid expired CA certificate, and it's going to throw it out. It's going to reject that certificate. So we want to enforce this constraint, and this is just an example that shows how to enforce that constraint. You may have other factors in your environment that lead you to choose validity periods differently, but what we do is start with the end entity certificates that we're going to issue. And in this case, I have a 1-year end entity certificate, and I'm going to renew those about every 9 months, and that's shown in the diagram. Once I know how long my end entity certificates are going to last, I can define how long I want my issuing CA certificate to last. And in this case, a good rule of thumb is to multiply the lifetime of the level below by 2 or more, and then add some buffer time so that you give yourself a chance to renew the certificate before it expires. So in this case, or actually replace the CA if that's what you're going to do. So in this case, I chose a 3-year validity period for the issuing CA, which is 2 times the 1 year of the level below, plus 1 year for buffer time. That buffer time depends on your environment, but if you think your process for replacing the CA could slip, you just want to give yourself enough time to replace it. And then for the root CA, I have a 10-year root CA, and this is what Ram showed in the demo as well. And I took the 3-year lifetime of the issuing CA, multiply it by a factor of 2 to get 6 years, and that's how often I'm going to replace the root CA. And again, this is a case where the root CA typically takes more time to distribute to every instance or device, every client in your environment. So you want to have a longer buffer time to allow yourself time to distribute the roots. So this is just a guideline for how to set the CA validity period. And last, some things to think about for operations. Ram mentioned that we want to think about automation for distributing root certificates to trust stores in your environment. You typically want to have automation to do this, and you can build your roots into your trust stores when you're establishing images, or distribute them in another automated fashion. The key point is that process has to be trusted. You've got to make sure that you distribute only root CA certificates or public keys that you trust and none that you don't trust. I talked a little bit about revocation and vending status information. That's something you need to think about, making sure your CRLs are reachable from all of your clients in your environment. And finally, redundancy and disaster recovery. ACM Private CA has an SLA of 99.9%, but you still want to think about, in your environment, what happens if that CA is not reachable? Does your environment fall over? What are the consequences? And based on your answer to that, you want to think about, do you want to have multiple subordinate issuing CAs that your devices or your infrastructure can access in the event of a failure? And you want to think about potentially having a single root CA and multiple subordinate issuing CAs in multiple regions. ACM Private CA is available in 17 regions, 15 commercial and 2 GovCloud US regions. But you want to think about your redundancy story and disaster recovery. And we can certainly help you with that, and our account teams can certainly help. But those are some of the things for operations that you want to think about. And so that's all I have for a prepared demonstration and talk. And at this point, I welcome you to ask questions. And we have about 15 minutes left for Q&A. First question? The question is, are there any plans to attach an MFA account authorization to the account where the root CA lives? It's certainly possible. That's sort of an independent process right now. So if you have MFA configured for the account, your login and is governed by that MFA process. The question is, can you integrate MFA into the process of issuing a certificate? Yep. Go ahead, Ram.
Can you enable? Oh, yeah, okay. Yeah, yes, you can. I mean, you can use a string condition with MFA within your policy to check for the MFA target itself. Yeah, you can do that. Yeah.
Thanks, Ram. Next. Another user. So the question is, can you have one user request a certificate and a separate user that sort of approves or holds the certificate until it's approved? Today, that's not possible. The way Private CA works is there's an issue certificate API and a get certificate. And so if you have permission to issue certificate, the CA is available, it just issues the certificate. Thank you for that. It's a suggestion we'll consider for a future release.
Is there any integration to support OCSP rather than CRL?
That is a common feature request, and the question was the OCSP versus only supporting CRLs. That is a common feature request, and it's definitely one that we're considering for a future release.
Two questions. So the first one is, what is your current backup strategy, like, especially for the root CA? Do you have a kind of redundancy, somehow kind of disaster recovery case? The second question is, if I want to build a kind of self-service type of certificate issuing or provisioning, so that the end user will basically want to kind of log on to portal and we can automatically request a CA delivered to them. So do you have API to support that kind of auto provisioning?
Yeah, so two questions were, one, redundancy of the service, and two, APIs to support a sort of client self-service portal for issuing certificates. So as far as redundancy, ACM Private CA is built on multi-AZ redundancy. In every region that we operate, the infrastructure that provides the service is deployed in each AZ in that region. So that's the redundancy story for delivering the service with high availability. In terms of a self-service portal or APIs, everything that we do for Private CA has an API. So everything you see in the console for issuing certificates, for creating the CA, everything can be done through an API. One thing I will explain, so Ram showed how to request a certificate through AWS Certificate Manager. And in that scenario, AWS Certificate Manager generates the private key, makes the request to the private CA, and then manages that certificate, renews it when it's in use. You can export a private certificate, and ACM will tell you, send you a CloudWatch event when it's been renewed, and you can pick up the new certificate. So that's the sort of rich functionality for certificate management that the Certificate Manager provides. If you want just a standalone certificate authority, Private CA provides just the CA as a service where you manage the certificate and the private key, you take care of renewals, but there's sort of two modes of operation, and I wanted to explain that because in terms of your question about a self-service portal, ACM does provide some of that certificate management capability. It's available in a console today, and you can look at that and look at that console and see if that works for you. But if not, you can either use the ACM APIs to request certificates where you get the certificate management, or you can go all the way to the standalone CA and request certificates directly through those APIs. Cross-signing CAs for, I'll let Ram give you the mic.
I was just wondering if you currently support cross-signing CA for another PKI hierarchy.
Yeah, so the PKI hierarchy you create is really totally flexible. That process I showed in somewhere around the middle of the slides where you create the CA and then generate a CSR, you can take that CSR to any parent CA and sign it, and then import the signed CA certificate. And that changes your private CA certificate authority up to whatever parent signed that.
But I'm curious, can you cross-sign from two different root CAs?
Cross-sign with two different root CAs? No. So ACM Private CA, the way the chain is constructed is it assumes it has one parent. And so there's no way to import sort of a second certificate from a second parent that would be necessary for a cross-sign. Next.
When you were filling out
looked like this certificate signing request, you basically were setting all the organization parameters and whatnot. Can I restrict a user to only be able to request certs to be signed with, you know, kind of, say, a particular subdomain?
So what you actually saw was him creating the subject of the certificate authority. That is used to fill in the CSR, that's correct. As of today, there isn't a way to restrict the domain names on which a certificate can be issued. That's something, we have a number of customers that have requested that feature. It's something we're thinking about building in, but what some of our internal and external customers have done is stand up a proxy gateway where they take the request and reject it if it's not in the domain that they want. It's not great, but that's something we're definitely thinking about, but that's a workaround for now.
So based on what you have said, I can bring my own CA into the chain, right?
That's
so
right.
I can chain to your, as a subordinate CA.
That's correct.
That's correct. Okay, another question is, can I limit the trust to a part of the chain so that I have like hierarchy and I want to trust only the leaf CA that actually issued the certificate and not the whole chain?
You could do that by distributing the certificate of the subordinate CA as the trusted entity and put that into your trust stores. So the question was, how do you, if you have a subordinate CA that's not the root, can that be trusted in your environment instead of the root? So you could, essentially that becomes a trusted CA that's distributed to trust stores.
Yep, this is for the browsers, for the things that are outside of the infrastructure, but if I'm using it also for the infrastructure.
So to be clear, this infrastructure is all private certificate authorities chaining up to a private root. ACM does support issuing publicly trusted certificates, but those are completely separate from private CA. If you want any browser, so all browsers have trust stores, and the trust stores come pre-installed with the roots from public CAs. Amazon is a public CA. We issue certificates through ACM that are already installed in browsers. So you can use ACM public certificates that would be trusted by default by browsers, but private certificates aren't trusted by default by browsers. That's what Ram showed when he installed the root into the trust store. That's why he had to do that before it was trusted in the demo. Did I answer your question? Thank you.
This is backed by a level 3 HSM, you said? Is that shared or dedicated to my use? Or should I be using Cloud HSM if I want that, or is that possible?
If you want a dedicated single instance HSM that you control the keys for, you should use Cloud HSM. The HSM is part of the service, and so your key is only used and decrypted in the memory of the HSM, but it's not, the HSM itself is not dedicated to you. Any other questions? Yep.
You mentioned in the best practice to set up a CNAME with your CRL to something else like CRL for something that already identified. Is that set in the private CA configuration?
Yeah, the question is, I recommended using a CNAME for the CRL to the S3 bucket, and that is part of the CA configuration. I think it's under advanced, so we might not have seen it in the demo, but it's just a name that you specify as a friendly name instead of the S3 bucket, and that name is what is populated into the certificates under the extension that tells the client where to look for the CRL. Question?
Do you have a rough timeline for your OCSP signing key capability at the moment?
I'm sorry, but in this forum, I can't give you a timeline, but I can just say it's it's a feature we're definitely considering for the future, and we can maybe talk offline about dates. Okay, any other questions? If you have any more or think of any other questions, I'll be around. Just let me know. Thank you all for your attention.
Thank you.
Well,